All right, students, for this assignment, you should write what I write and draw what I draw. We're going to be talking about permeability, which is a measure of how well a substance, and in these instances we're talking about rock or soil or some kind of sediment, transmits water. And permeability is different than porosity. Porosity is a measure of the spaces in a rock or soil. So porosity is how many holes there are. Permeability is how well water passes through. There can be a bunch of holes, and if the holes aren't connected, a substance will be still less permeable. And I'm going to draw 4 boxes. Each box is going to represent a rock or a soil sample or a sediment. And the first one is going to be bedrock. Bedrock is solid rock, so I'm just going to shade the whole thing in, kind of scribble. And bedrock is impermeable. That means water cannot pass through, and it is non-porous, meaning it doesn't have any holes. The second sample we're going to call gravel, and gravel is generally a well-sorted sediment. So we're going to represent that by these little pieces of sediment, or call them pebbles or something like that. These are roughly the same size. They don't have to be perfectly the same size, but roughly the same size. When you have well-sorted sediment that is roughly the same size, you're going to have a sample that is both porous and permeable. And to represent that it's permeable, I'm going to take a blue pen, if you have one, or a colored pencil or something, and just draw some lines here that show water passing through. And water can get from one end to the other because there's a bunch of space and it's all connected. For the third box, we're going to say it's a mix, and that's going to be gravel, sand, whatever else, and it's going to be poorly sorted, and it's going to be low porosity and low permeability. And we're going to represent that by sediments that are all different sizes. And what happens here is the little pieces stick into the spaces between the big pieces, and water can't get through. So there's not really too many spaces. There might be a few, but you have a lower permeability than you do with the gravel. And then the final thing I'm going to draw here is what we're going to call creviced rock. Creviced rock has high porosity because it has a bunch of holes in it, but low permeability. And so we've got this sample of rock. It's kind of like bedrock, but it's got spaces in there and these kind of like pockets where water is hanging out, but the holes aren't connected. So crevice rock, we'll do one more. High porosity, low permeability. The next thing I want you to draw, this is going to be kind of separate. The next thing we're going to draw is like a little more complicated water table diagram that's going to include more stuff. So this represents the surface. On the surface, we're going to have a tree and a person with a shovel, because they might be digging a well. It's an old-timey well with a bucket. And that's all we really need on the surface. You could put a little house for the stick figure if you want. We're going to have the water table with a little bit of a cone of depression there near the well. And at the bottom, we're going to have an impermeable layer. That impermeable layer is going to be represented by kind of a crosshatch. So this is your impermeable layer. And then you've got, we're going to have another layer, another impermeable layer, beneath that with a space in between to show an aquifer. And this would actually be called a confined aquifer, because the water is trapped between two impermeable layers. We'll go ahead and label the water table. And we'll label the zone of saturation and the zone of aeration and the cone of depression. And just so that things are clear and you see how everything's connected, we're going to go ahead and make the soil horizons here. So at the top, you got the O horizon, the organic horizon. Then the next layer is going to be your topsoil. That is your A horizon. At the bottom of the topsoil, you have your E horizon, or your alluviated layer. Beneath the alluviated layer is subsoil. And then you have your regolith, or partially weathered bedrock. And then you've got your bedrock. So this is all bedrock down here, this impermeable layer. Go ahead and label the well here. And one thing to understand is that where this water table exists, it's all underground. So there is soil and stuff throughout here. The zone of aeration is going to be a mix of soil and air and a little bit of water. The saturated zone is also going to have rocks and soil and sediment in there, but it's just full of water as well. So that is your assignment, to draw these diagrams.